Example, show that the matrix A it is equals to say 1 2 minus 2, but minus 6 minus 1 2, minus 6 minus 1 2, and then 6 2 minus 1 and 6 2 minus 1. 7 2 minus 2 minus 6 minus 1 2, 6 2 minus 1 satisfy the Cayley Hamilton theorem. Satisfy the Cayley Hamilton theorem. The matrix A is given and we have to prove that it satisfies the Cayley Hamilton theorem. So for this one we will write down the solution. First we will find out lambda I minus A, it is equals to lambda I, that means lambda 0 0 0 lambda 0 0 0 lambda minus A. A means 7 2 minus 2 minus 6 minus 1, here is 2 and here is 6 2 and minus 1, 6 2 and minus 1, it is equals to this lambda I minus A, it is equals to what it comes. This is 7 this is lambda minus 7, so this becomes lambda minus 7, 0 minus 2, so that means it is minus 2, and 0 minus minus 2, that means it becomes plus 2, 0 minus minus 6, that means it is 6, and lambda minus minus 1, so that means it is lambda plus 1, and 0 minus 2, so that means it is minus 2, 0 minus 6, so that means this is minus 6, and 0 minus 2, so that means it is minus 2, and lambda minus minus 1, so that becomes lambda plus 1. It must be equals to 0. It must be equals to 0. So lambda I minus A, it is equals to lambda minus 7 minus 2 plus 2, 6 lambda plus 1 minus 2 minus 6 minus 2 and lambda plus 1, it is equals to 0. So this is lambda I minus A. Now we will expand this one. Now we will expand this one and we will find out our characteristics equation and our characteristics equation. Now see here, this we can find out lambda I minus A, it is equals to, now see here, this is what lambda minus 7 multiplied by these two minus these two, so this is lambda plus 1 into lambda plus 1, this is lambda minus 7. Now we will find out lambda minus 7 in bracket lambda, what is this, plus 1 lambda plus 1, lambda plus 1 lambda plus 1, and this is minus 2 into minus 2, that is 4, so this becomes minus 4, minus 4, this is minus 2, so minus 2 becomes plus 2 in bracket, so this is lambda plus 1 into 6, and this is minus 12 means plus 12, 6 into lambda plus 1, 6 into lambda plus 1, and this is minus, minus 12, minus 6 into minus 2, that is minus plus 12 means this is here minus 12, and this is 2, so this becomes plus 2 multiplied by, this is 6 into 2, that is minus 12, that is minus 12, and this becomes minus minus plus, so lambda plus 1 multiplied by minus 6, so minus minus plus, so this becomes plus 6 multiplied by lambda plus 1, lambda plus 1. So now if we solve this one, then we have lambda I minus a, this is equals to 0, this completed is equals to 0. So this lambda minus 7 we will take as it is, lambda minus 7. We will solve this one. So this becomes lambda square plus 2 lambda plus 1 minus 4. Then this becomes plus 2, and here we have 6 lambda plus 6 minus 12, plus 6 minus 12. So that means how much it is? Plus 6 minus 12, that means minus 6. Okay, and here plus 2, and here is the 6 into lambda, that means 6 lambda plus 6 minus 12. So again 6 lambda minus 6, it is equals to 0. It is equals to 0. So 6 lambda minus 6, 6 lambda minus 6 into 2 into 2. So these are the two similar terms. So this we can write down lambda I minus a, it is equals to lambda minus 7 in bracket, this becomes lambda square plus 2 lambda plus 1 minus 4. So this becomes minus 3. So this becomes minus 3, and this is this term and these terms are same, so we can write down plus 4 multiplied by 6 lambda minus 6. This gets doubled. This gets double. So 2 plus 2, that means it becomes 4. 4 multiplied by 6 lambda minus 6. If we add these two, then we get 4 multiplied by 6 lambda minus 6. Now we will expand this one. Lambda I minus a, it is equals to 0. So we will have this one. So lambda square plus 2 lambda minus 3 multiplied by lambda minus 7. Lambda minus 7. So it comes lambda cube. This is 2 lambda square and this is 7 lambda square, that is minus. So this becomes 5 lambda square, and then this is 3 lambda. This is 3 lambda minus 3, and here it is minus 14 lambda, minus 14. So that means minus 17 lambda and 3 minus 3 plus minus 7. So this becomes plus 21 plus this is 6 into 4, that is 24 lambda minus 24, it is equals to 0. It is equals to 0. Now we will collect the similar terms. So lambda I minus a, it is equals to lambda cube as it is minus 5 lambda as it is minus this one. This is 17 and this is 24. Minus 17 plus 24, that is plus 7 lambda, and this is 21 and minus 24. So this becomes minus 3, it is equals to 0. So this is my equation A. This is equation A. Equation A is characteristic equation. Characteristics equation. Hence, this a cube, instead of lambda we will put a. So this becomes a cube minus 5a square plus 7a minus 3. This is constant, so we will multiply it by I. It is equals to 0. It is equals to 0. So it must be equals to 0. It must be equals to 0. So this is my Cayley Hamilton theorem. A cube, we will replace this lambda by a. So instead of lambda we will put a, so it is a cube minus 5a square plus 7a minus 3, and this 3 is constant, so we will convert it into the matrices form by multiplying it by the identity matrix.